Okay, let's take a quick look. Well, it won't be very quick, but let's take a look at number 38 and what I'm expecting you to do here. You're supposed to, the instructions at the top say, using graph paper, ruler, and protractor, draw to scale and add the following vectors head to tail. Measure the resultant using the protractor and ruler. Attach the graph paper to the end of this problem set. So before I even start using graph paper, I'm going to do a rough sketch of what this will look like. This will be very rough, but it'll show me at least what quadrant maybe I'm going to end up in. So here's the rough sketch. Okay, 15 degrees west of south. Well, here's south, and here's west. So 15 degrees would be this way, and I want to go 10. Now notice I have 10, 27, 31, 22. So the maximum is going to be 3. So I'm going to make this pretty short. Make it about like that. So there's 10 at 15 degrees. And then I want to go 27. So I set up another little axis here at the end of this one because it's head to tail. So I need to put the tail of this one 35 degrees north of east. Well, here's east. So that would be this way, 35 degrees. So I want to go 27, so that's going to be 2.5 times as long as that at about 35 degrees. So somewhere in there. Okay. And then I want to go 5 degrees north of east. Well, here's east. North of east is this way, just 5 degrees. So, but I'm going to go 31, which is a little bit longer than this. Okay, and then 20 degrees west of north. That's going to be this way. Here's north and here's west, so it'll be like at this angle 20 degrees, and I want to go 22. So I'm probably going to end up somewhere in this ballpark in this first quadrant. So I really don't need much of this area down here. So when I set this up on my graph paper, I don't have to worry so much about being centered. I can be pushed down to the left. So what I'll do is on my graph paper, I'll have it down here. And let's see, I think instead of, it says, it doesn't really give us a scale. So, but 30, I'll make, just to make it big enough, I'm going to make 1 inch equal 10 kilometers. So 1 inch equals 10 kilometers. So I need to set me up an axis. So I'm going to do it down here. Like I said, I don't need a whole lot off to in the second, third, or fourth quadrant, but I do need a lot in the first quadrant. So this will be my x-axis all the way across here. Okay, or I guess I should say it's x, but it's also east. And then I'll make my north-south about here. Lined up the best I can. Didn't do a very good job, but it'll be good enough. I can use the rest of the axis. So this will be the y-axis or north. This is south and west. So the first one is west of south, 15 degrees. So get our protractor. Let me slide this up where you can see what I'm doing. Okay, so 15 degrees west of south. Well, here's south. Go west of it, 15 degrees. There's 10, 15. So I made me a little mark. Now I want to go 1 inch because I'm supposed to go 10 centimeters. I mean 10 kilometers, my bad, in that direction. Okay. Okay, so this angle here is 15, and this vector is 10 kilometers. Now you set up another axis right here, another axis, temporary little axis, because that's where your next vector is going to go from, the tip of this one. So you have this like little temporary axis across here, and we want to go back to the directions. It says then go 27 kilometers 35 degrees north of east. So I put my protractor on here. Might as well turn it over where I can see it a little better. Don't have to have it over on that side because I can count. So I think I've got it on the tip there. Got my axis lined up, and I want to go, I had it lined up until I turned it. I want to go 27 kilometers at 35 degrees north of east. 10, 20, 35. Notice east is this way. Going north of that is this way. So there's 35. So, and I want to go 27 is what it says. So that would be almost 2 3/4 inches. That's the problem when you're dealing with inches, is they're not marked off in decimal. 3/4 of an inch is 0.75. 5/8 is, what is 5/8? See, that's the problem. You have to divide. 5/8 is 0.625. 11/16 is 0.6875. So it will be somewhere between the 3/4 and 11/16. So say right about there, maybe. That's 5/8, and that was 0.625. That's 11/16. So it needs to be in between there. So there's where that vector ends. Notice that this angle here is the 35 degrees that it's talking about, and this is 27 kilometers. So my rough sketch wasn't very good. I had it down here, but it's not way out of range. So now we want to go 35 degrees, or 31 kilometers, sorry, I don't know where I saw that at, 5 degrees north of east. East is this way, so let me set up a little axis right here to go off of, try to get it parallel with my grid the best I can. Okay, so I want to go 5 degrees north of east this time. So I line up on this, get it as parallel to the axis as or my grid as I can, and go 5 degrees. That's right here. Okay, 5 degrees. So, and I want to go 31 kilometers towards that, which would be 3 inches and a little bit. Did I do that right too? Yep. I don't like starting at the end of the ruler, as you probably noticed, so I always have to count over. Well, 1/16 is 0.625, so it's going to be a little past that 16th mark when I get there. So let's see, almost running off my grid. So 10, 20, 30 kilometers, and then 1 is going to be like right about there probably, because this is 0.125. So it's going to be just to the edge of the grid. Boy, that was close. All right, and then the last one, 22 kilometers, 20 degrees west of north. Well, I hit the edge there, so I'm just going to use that edge. And I have to go 22 degrees. This is north. I want to go 22 degrees west of north. So that would be, whoops, 20 degrees, my bad. Well, almost boogered that up, didn't I? Right there. And I want to go 22 kilometers. Well, that's a little under 2 1/4 inches. So there's 1, 2, there's a quarter, so it's going to be right about in there. 3/16, just to give you an idea, which is the mark before the quarter, is 0.1875. So it's going to be in between this mark and that mark, about halfway in between them. There are some scales that you can buy that are marked off in inches, but then the in-betweens are marked off in decimal, like by tenths. There'd be 10 marks in between there. There are engineering scales for use in big engineering projects where they want scales like that. So there's where we ended up. This angle here was 20 degrees. This angle here is 5 degrees. This length, 31 kilometers. This length, 22 kilometers. So you were told to find the resultant. The resultant is start where you started and end where you end. So we're going to start here and go to where we end, and then we're going to also measure that angle. Okay, so this is the resultant, this vector here from where we start to where we end. Let me measure the length of it. I better use a bigger ruler. Now notice this ruler, they were kind enough to not put the 0 at the very end of the ruler. So we get like 5 3/16. 3/16, that'd be like 52 kilometers. 10, 20, 30, 40, 50, 52 kilometers. And the angle is, looks like almost 45, 44 and a half. So somewhere between 44 and 45 degrees. So I'll just make it 45 degrees. So we would say that our resultant, call it R, is 52 kilometers, 45 degrees north of east. Now, if we were really talking using the northeast, south, and west coordinate system, you really wouldn't even have to have the 45. You could say 52 kilometers, 45 degrees northeast, because when you say northeast, you're implying 45 degrees. While we're doing this, though, let me check this to see how close I am in all of this measuring. Now, this is not what the sheet asks you, but it may be instructive in helping you understand how to add vectors. And even if you wanted to do it, this is adding them graphically. We actually just drew them out very precisely to see what the resultant would be. But what if I wanted to add them algebraically just to check myself? Well, you remember in the other video that any vector A can be broke up into its components a sub x and a sub y by taking the magnitude of A and multiplying it by the cosine of the angle, and for y, sine of the angle. If we do that for every one of these and add their components, we will get the components of the resultant vector. So I'm going to make a table over here, and I could number them 1, 2, 3, and 4, but I'm just going to start at the beginning and work my way around. We'll have the x components, or east, and the y components, or north. Okay, the first one, to get it, we need, remember, these equations only work if you take the angle theta has to be from plus x-axis going counterclockwise. So if this is 15 degrees, then coming from the x-axis around would be 270 minus 15, which is 255. So we'd have cosine 255, sine 255, and then we'd have 10 out here because that's the length of the vector. Okay, that's the first one. The second one's, well, that is with the x-axis, so it'll be cosine 35, sine 35, and the length is 27. The third one, it's with the x-axis, so we're good. Cosine, sine. Almost messed that up, didn't I? I don't know if you caught my flick of the pen there. And then this last angle will be 90 plus 20, which is 110. And its length is 22. And then what I'm going to do, those are the components. I'm just going to add them straight down. Add all this, add all this. And then I'll get, this will be R. This will be the components of R. This would be the X this way and the Y this way. Okay, so let me add those really quick as I can doing this. Clear, we have 10 cosine 255 plus 27 cosine 35 plus 31 cosine 5. I probably ought to put parentheses around that. I don't know how the calculator will respond to that. Plus 22 cosine 110. And I get 42.89. Do the X or the Y the same way. 10 sine 255 plus 27 sine 35 plus 31 sine 5 plus 22 sine 110. We get 29.2. Let's see if that's even close to what I show here. Well, 42 would be about 4 1/4 inches. Sure enough, there's 4 1/4. And then up and down should be almost 3 inches, and it is. So how do we see exactly what this vector is? Well, think of this vector here as being the components of a vector. This way, 42.89 and 29.2. So the resultant, which I'll use red again, this is just a sketch. So think of this length, R, using the Pythagorean theorem. You would see that R would be the square root of 29.2 squared plus 42.89 squared. So the length of R is, let's punch that in, we get second square root 29.2 squared plus 42.89 squared. 51.88 kilometers. Well, that rounds to 52, which is what we found graphically. The angle theta, let's use the tangent because we have the opposite and the adjacent. So we'll actually use the inverse tangent of 29.2 over 42.89. Let's punch that in the calculator. Second tan, 29.2 divided by 42.89. Gives us an angle of 34. Ooh, I measured something wrong. 34.25 degrees. What did I do wrong? Did I not? That's obviously not 45. I must have looked at the wrong angle. And I did. Look what I did wrong. It's 34.5, not 45. So this should have been 34.5 when I measured it. So notice I found out that I goofed by using the algebraic method. I figured out that I had actually goofed up here when I measured the angle with the protractor. That's probably the most difficult problem on the whole set. Others, you're only adding 1 or 2 vectors, maybe 3. So that gives you an idea of what I'm expecting, how to handle it. Notice it's vector from the head of that one, You put the tail of the other one and take off, head to tail, head to tail, head to tail. Your final vector, your resultant, you go from where you begin to where you ended. So the vector is actually pointed that away. That's the end result of all of these displacements. Okay? All right, have fun.